Scaling TensorFlow with TensorFlow Serving and Kubernetes. Scaling TensorFlow with TensorFlow Serving and Kubernetes involves deploying TensorFlow models as scalable and reliable services on Kubernetes clusters using TensorFlow Serving. This allows for efficient serving of machine learning models, handling various levels of workload and ensuring high-level availability and scalability. Let's dive deeper into the key concepts and steps involved in scaling TensorFlow with TensorFlow Serving and Kubernetes. Let's go first with TensorFlow Serving. TensorFlow Serving is a flexible, high-performance serving system for deploying machine learning models in production environments. It provides a platform-agnostic interface for serving TensorFlow models over a network and includes features such as model versioning, monitoring, and scalability. Key components and features of TensorFlow Serving include servables. TensorFlow Serving organizes models into servables, which represent the different versions of a model that can be served. Each servable is associated with a unique version number and can be loaded and served independently. Loaders. TensorFlow Serving uses loaders to load and manage servables in memory. Loaders handle tasks such as model initialization, version management, and resource allocation. Predictors. Predictors are responsible for handling inference requests and generating predictions using loaded servables. TensorFlow Serving supports various prediction APIs including gRPC, HTTP REST, and TensorFlow Serving's native API. Let's look at Kubernetes. Kubernetes is an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications. Kubernetes provides features such as service discovery, load balancing, autoscaling, and self-healing, making it well suited for deploying and managing distributed systems at scale. Key components and features of Kubernetes includes pods. Pods are smallest deployable units in Kubernetes and encapsulate one or more containers. Each pod has its own IP address and resource allocation, making it a logical unit of deployment for containerized applications. Deployments. Deployments define the desired state of a set of pods and manage their lifecycle. Deployments handle tasks such as pod creation, scaling, rolling updates, and self-healing in response to failure or changes in resource requirements. Services. Services provide network connectivity to pods and enable communication between different parts of a distributed application. Kubernetes services abstract away the underlying network topology and provide a stable endpoint for accessing pods. Last one is scaling TensorFlow with TensorFlow Serving and Kubernetes. To scale TensorFlow models with TensorFlow Serving and Kubernetes, follow these steps. First, containerize TensorFlow models. Package TensorFlow models as Docker containers with TensorFlow Serving installed. Define a Docker file to specify the model serving environments and dependencies. Next, deploy the TensorFlow Serving on Kubernetes. Create Kubernetes deployment and service manifest to deploy TensorFlow Serving instances as pods. Specify resource requirements such as CPU and memory limits to ensure efficient resource utilization. Next, expose TensorFlow Serving service. Expose the TensorFlow Serving service using Kubernetes service objects. Define a service of type load balancer or node port to provide external access to the TensorFlow Serving endpoints. Next, load and serve TensorFlow models. Use TensorFlow Serving configuration option to specify the model path and version to serve. Configure TensorFlow Serving to load models from storage, example Google Cloud Storage, Amazon S3, and serve them over HTTP REST or gRPC endpoints. Next is scale and manage TensorFlow Serving instances. Use Kubernetes features such as horizontal pod autoscaling (HPA) and cluster autoscaler to automatically scale TensorFlow Serving instances based on resource utilization and incoming workload. monitor TensorFlow serving pods and services using Kubernetes monitoring tools and dashboards. Scaling TensorFlow with TensorFlow Serving and Kubernetes enables efficient deployment and serving of machine learning models in production environments. By containerizing TensorFlow models, deploying them as scalable services on Kubernetes clusters, and leveraging TensorFlow's serving features for model serving and versioning, developers can build robust and scalable machine learning pipelines that handle varying levels of workload and ensure high availability. Understanding the key concepts and steps involved in scaling TensorFlow with TensorFlow Serving and Kubernetes is essential for effectively deploying and managing machine learning models at scale in modern distributed systems.